Hi, my name is Twisha, and in this video, I'm going to talk about the public lecture that I attended on October 14th called The Surprising Expansion of the Universe, hosted by Professor Adam Rees. The main idea of the talk was to talk about how we actually measured the expansion of the universe and how these measurements led to one of the biggest surprises in modern physics, that the discovery that the universe is not just expanding, but it's actually accelerating. So before this lecture, I knew the basic Hubble story, which is that distant galaxies have redshifted light because they're moving away from us, which means that space itself is expanding. What I didn't really realize is how astronomers and scientists measure distance, which is very critical to figuring out how fast the universe is expanding. The lecture introduced us to the idea of standard candles, especially type supernovae. So these explosions essentially always reach the same brightness, which means that if one looks dimmer, it's farther away. That relationship between brightness and distance is similar to the inverse square law, which is something that I've seen in physics class, but I've never seen how it was used to measure the entire universe. It has some very wide applications. Something else I didn't know was that Einstein originally thought that the universe was static. So when he was doing his math and his equations, he found that they actually did predict expansion or contraction, but he himself didn't believe that. So he added something called a cosmological constant to force the universe to stay still in his calculations. Later, when the expansion was discovered, he called this his greatest mistake. But all of this ties back to the idea of dark energy, which I'll get into. So one of the most interesting parts for me was how scientists discovered that the expansion was actually accelerating. When they were looking at the supernovae, they were looking a lot dimmer than expected. So at first they were worried that something was wrong with the cameras or the supernovae were being weird. But after finding even more distant supernovae, they realized that the universe itself must have been expanding slower in the past than it is now. So it's still expanding, but it's expanding even faster. So there's acceleration. And this is what led us to the idea of dark energy, which makes up 70% of the universe, and then the rest is dark matter, gas, stars, and then we don't even account for planets. I think the thing that really got me curious was the fact that we don't actually know what dark energy is. The lecture talked about 3 possibilities. So it could be just vacuum energy, like the cosmological constant. It could be something dynamic, or it could be something as crazy as like gravity being different. As a biomedical engineering student, I'm obviously not working on cosmology every day, but the idea of using such indirect measurements to infer something as big of the fate as the universe reminded me how we can measure different things in our lives similarly. Just like how astronomers are using things that they can't even touch, biomedical engineers can also do that with different types of physiological signals. So I thought it was a very cool link. I think that the best part about this entire experience was seeing how Dr. Rees's team was reacting in real time. He shared that he was on his honeymoon during this big discovery, so everyone was kind of communicating across the globe, and it was honestly really cool to see how everyone thought this was something absolutely outrageous and not true, but then they ended up winning a Nobel Prize for this, which I thought was absolutely amazing. I also ended up following up and learning a little bit more about the Chandrasekhar limit, which was actually very cool. It ended up being something very pivotal for discovering dark energy, even though it wasn't like created or found with that intent. So overall, the lecture helped me understand not just that the universe is accelerating, but it also gave me the evidence of how we know that. Dr. Rees really broke this down and made it very digestible for all of us to understand, and it was honestly a great lecture because he was so engaging. It sparked my curiosity about dark energy, and I want to learn more about it, honestly. It made me appreciate how precise measurements and clever physics can really uncover huge truths about our world. Thank you!